Welcome back, everybody. This is going to be our next notes video. It's going to be pretty short notes-wise, but there's going to be an example problem that's going to take a good chunk of time, or two example problems, I should say. But we had been working with moles. Moles is kind of the big focus of this chapter, as you figured out, I hope, by this point. And we were doing earlier moles to particles conversions. Now, just as a clarification, because I had a couple of questions about it, particles, in case you missed it in the last video, particle is a catch-all term that can be used for any either description that you would use of something that's a compound. So you could use a particle to talk about an atom. If you were talking about like sodium, you could say a particle of sodium. That would be the same as an atom. But you could also say a particle of water, and that would be a molecule of H2O. Particle is just a way that you can talk about them without accidentally getting it wrong by calling an atom a molecule an atom, or vice versa. So I don't really have to worry about being incorrect. So I use particle a lot as a catch-all. But if the question asks you about atoms or formula units or molecules, all of those fall under the category of particles. So hope that cleared up that confusion. For now, though, we're going to be talking about mass. So we're no longer working with Avogadro's number. We used Avogadro's number to exchange between moles and particles. But we also learned earlier in the chapter that the numbers on the periodic table are actually already a conversion factor. They can go from grams to moles. You know how many grams there are in 1 mole of a substance by looking at the periodic table. So that means if you know the mass of a sample of a certain compound or element, you can figure out the moles. And if you know the moles of that compound or element, you can figure out the mass of what you have. So we're just going to do 2 example problems here. One's a little easy, one's a little more difficult. You've got how many moles are there in 6.54 grams of calcium. And then number 2 is your experiment needs 0.852 moles of lithium nitrate. How many grams is that? So if you want to pause the video and attempt these by yourself, you're welcome to do so. I am going to move over to our hand cam, and we're going to try to work this out. So starting with the first one, moles that are in 6.54 grams of calcium. Well, we're going to start with that number that we got here, our 6.54 grams of calcium. And then anytime you're doing any of these conversion factor questions, your brain should immediately go, can I convert directly into this, or do I have to make a stop in between? And in this case, is there a conversion that goes between grams and moles? Yes, we look at the periodic table. So if you look at your periodic table, you will find that there are 40.08 grams. Now, I want you to think, why am I putting this grams on the bottom? If you said because there's a grams on top, you are correct. And then we're going to do 1 mole on top. This number just comes directly from the periodic table. 40.08 grams is the formula weight of calcium on the periodic table. If we do this, that will cancel out grams, and we'll be left with an answer in moles, which is what we want. So we're good to go ahead and plug that in. So I'll bring on my calculator. Now, thankfully, I'd already done this because I had to re-record this video once already because, I'm bad at this a little bit sometimes. So I know you all think I'm a perfect human being, but definitely not. So we've got 0.1631736.527. Before we write that down, though, you notice last time we did this mental exercise where we asked ourselves, does that number make sense? So I'm going to ask you that question right now. Does that number make sense? Having 0.16317 whatever moles of something. And hopefully you think, yeah, that does make sense. Moles is a really, really big thing. It's a really large amount of something. So it makes sense to have like a decimal of moles. That just means you have less than a whole lot of that thing. It's still going to end up being a whole lot, though. The difference would be if we were talking about like grams, like that's a really small amount of grams. Or if we were talking about particles, you can't have 0.16 of an atom. That doesn't make sense. So just keep that in mind as we go through here. Your particles numbers should be times 10 to some large number, like 20 plus. Sometimes it could be smaller. Sometimes it could be like 18, 19. But you should never have like 3 or 4 particles. If I do that, I'm either trying to make a tricky question or you've done something wrong if you get that as your answer. Moles, it would make sense to have moles somewhere probably, close to like 1 maybe a little bit above, maybe a little bit below, but that's probably a reasonable range. Again, not always, but it's a general rule you can follow. And then your grams numbers should be, probably like bigger than 1, but usually smaller than like 100, something like that. I don't know. I'm just trying to give you a general rule there because I know some of you like really specific numbers for it. But after you do this enough, you'll get a feel for when a number seems really big or seems really small for what you're using. In this case, though, this number seems right. It's a decimal, but we're talking about moles, so we're going to go ahead and run with it. In this case, I had 6.54. I'm not going to use this for my sig figs because it came from the periodic table, and we just always go to 2 decimal places for the periodic table. So my answer should have 3 sig figs. So my answer will be 0.163 moles. And then remember, you want to also put not just that it's moles, but moles of calcium. You have to have that part in your unit as well. Okay. The next example is a little bit tougher. This one is you have 0.852 moles of lithium nitrate. Well, the first thing we're going to have to do is we have to figure out what lithium nitrate actually is. So lithium is Li. And then nitrate, well, nitrate's a polyatomic. So hopefully you're still feeling pretty good about knowing your polyatomics. In this case, nitrate is N because it has nitrogen, and then it has O's. How many O's does it have? Well, it has 3. And then what charge does it have? I'll give you a moment to think about it. And it has a -1 charge. So NO3 minus, and then Li, if you look on the periodic table, has a plus charge. We're going to cross our charges, but we don't really have to because they're the same. So lithium nitrate is LiNO3. Okay, our problem says we have 0. And then 852 moles of LiNO3. And we want to go to grams. Do we have a way that we can convert directly from moles to grams? Yes, we do. So we're going to put a moles on bottom, and we'll put a grams on top. And the way we do that is by using the molar mass or the formula weight. So we're going to have to go, but we can't just look up on the periodic table lithium nitrate's mass. We instead are going to have to combine together the masses of all of the pieces. So this is where that molar mass worksheet kind of becomes important. So we've got Li, we've got N, and we've got O. If I'm not moving my hand away enough so you can actually see what I'm writing, please let me know so I can try to fix that in the future. Li, on the periodic table, there is 1 of them, and it has a mass of 6.94. N, there is 1 of, and it has a mass of 14.01. And then O, there are 3 of them, and it has a mass of 16.00. It's like 15.99999, but on the periodic table I gave you, I just rounded it to 16. So we've got 6.94, 14.01, and then 16 times 3 is, I believe, 48. You didn't see that. I didn't almost write it wrong. That would never happen. Okay, let's add all these pieces together. So we got 6.94 plus 14.01 plus 48. And you might be tempted to use sig figs when you're doing this, but we don't really have to because this is technically a number coming from the periodic table. We rounded all of them to 2 decimal places, and so as long as our answer has 2 decimal places, which it should because we're only adding numbers that go to 2 decimal places, your answer should just be correct. So I'll go ahead and take this number. I'm going to write it just for my future reference that it is 68.95. I noticed a lot of you were adding the units on your worksheet. Very good. This is a grams per mole. So we're going to put this 68.95 with the grams, and then that is how many grams there are in 1 mole of lithium nitrate. But we only have 0.52 moles. So our moles will cancel. We'll be left with grams of LiNO3, which is what we're looking for. So I can plug that into my calculator. So I'm going to take this number because I already have it, and I'll just multiply my 0.852 by that number. And now I'll get a big number, or big-ish number, 58.7454. And then we ask ourselves the question, just like we did earlier, does this number make sense? And in this case, well, we're talking about grams. So grams, it should not be a super gigantic number. It shouldn't be a times 10 to the 23rd or anything like that. It also doesn't make sense for it to usually be like a decimal, like moles was over here. So this is a pretty reasonable number for what our grams could be. So we'll round it to 3 sig figs, because this 0 is not significant. It's before the decimal, and there's nothing else non-zero before it. So if we round to 3 sig figs, we get 58.7, and it's grams of LiNO3. All right, I hope that makes sense to everybody. If you have any questions, you can leave them into the box to the right. You can email me as always. As you probably noticed, pretty recently I actually was able to sit down and start grading your stuff, and I responded to a bunch of your comments. I really do appreciate that you guys are leaving feedback on what you don't understand, the video, the audio quality, and those of you that are sharing the pieces of stuff going on in your life or any cool stuff you're finding on YouTube or pictures of fun things happening in your life. I do really appreciate it. Miss all of you guys. Hope you're having a great time locked in your house with all of your family. My cats are getting pretty annoying, but we're surviving over here. So have a great rest of your day, everybody, and I will see you or hear from you soon.